All right, so we're in Calculus 1, and it is time to learn something called the product rule that you'll use throughout your entire study of calculus. Normally, calculus is broken down into Calculus 1, 2, and 3, and you'll use it all the way through, okay? So first we start with proper context. The product rule is how you take the derivative of a product of two functions. So I might look at this like function f times some other function g. All right? Kind of like, say, my first problem. The first function is 8 minus 2x to the third power and times this other function, which is 2 minus x. All right? So let's call those functions f and g. Here is how you find the derivative of a product, f times g. It's f prime times g plus g prime times f. And there are all kinds of ways you can remember that. I wouldn't surprise me if there's songs you can sing to remember, whatever. Like, people have their own ways of remembering this rule. But, you can use your notes, and if I was teaching this class on campus right now, I would give them a formula sheet. I'd put the product rule on it because, that's just the way I do it. But there it is. My focus is not on all the clever and cute ways you can remember that, but how you use it. All right, so I'm just going to go straight to the examples. Suppose we want to find the derivative of this function, 8 minus 2x to the third times 2 minus x. Well, let's make sure that we conceive of this the right way. I do see this as the product of two functions. That one I'll call f, and this one I'll call g. And it says, according to the product rule, that the derivative of such a function is f prime times g plus g prime times f. So let's see. F prime, can you tell me the derivative of 8 minus 2x to the third power? Just all by itself. F is 8 minus 2x to the third power. What is f prime? Now, I've made videos already about just how you find derivatives of more basic things, like 8 minus 2x to the third power. All right? Now, I'm really never opposed to reviewing. When I make the videos, if I reviewed every single thing that came up along the way, they would all be an hour and 45 minutes long. But, if you needed to review something, you could ask me to post a video specifically to review that topic. But this time I'll say, well, what if y was 8 minus 2x to the third power? What is y prime? Okay, so we take the derivative of each of these individually. We carry down the minus. What's the derivative of 8? That would be 0 because 8's a constant. We carry down the minus. What do we do with that coefficient of 2? Well, the rules of derivatives allow us to carry that down also. And we multiply it by the derivative of x to the third power, which is 3x squared. So all those rules were covered in other videos, and so you can always go back, and the videos are always there. They're not going away. You can go look them up if you need a little reviewing on the rules I mentioned right there. But that's it. So for just 8 minus 2x to the third, the derivative of just that's going to be negative 6x squared. Okay? So let's write down like this. We'll say f prime negative 6x squared times g being this function right there, that secondary function. So 2 minus x plus g prime. What's the derivative of 2 minus x? Well, at least the way that I taught you to do that kind of thing before is that if you looked at 2 minus x all by itself, that would be a line of slope negative 1. And the derivative of something does tell you its slope. So the derivative of 2 minus x all by itself is negative 1. All right, so I'm going to put a negative 1 like that. And then times f, g prime times f. F is 8 minus 2x to the third power. Okay, and there's the product rule. Now, I like to present this to you in a way where you can, you don't have to take a lot of notes. Like, you can hopefully watch this and you can see a lot of what you need to see. And some of you are like, might be watching this, say, oh, these videos are lousy. We have to take all kinds of notes and look up other stuff. Well, I'm sorry. Doing the best I can. So F prime G, oh, geez, G prime times F. All right. So there I'm labeling it. I guess that's all I was trying to say, is that not only am I showing the work, but I'm labeling it. There's F prime. There's G. There's G prime. And there's F. Okay. So let's see. Now, I guess like that could serve as an answer if I got everything in the right spot and so on, but we probably will simplify this. You know, it would be wrong if I didn't discuss that. Even though if, like, say you were using online homework and you type that in, it may very well accept it. But I'll go ahead and I'll multiply through now that I can see everything, and I'll combine like terms and so on. So I'll get negative 12x squared here. And then I'll get plus 6x to the third power right there. And then I'll get minus 8 here like that, because that's a negative 1, right? And then I'll get plus 2x to the third power, again, because that's a negative 1. And let's see, I get 2, and so 8x to the third power. To combine those like terms, minus 12x squared minus 8. Okay. All right, so then that's as reduced as it's going to get. I guess, like, could somebody factor a 4 out of this? Yeah, you could do that. I mean, it's like, how far do you want to go? I want to emphasize just using the product rule, and that's a perfectly good answer right there for our purposes. All right, now, since we're going to learn a lot of things, is there another way that you could have done this? All right. So just think about it. Right now I'm showing you the product rule because that's what I need to show you, but I'm definitely not I'm not saying that this is the only way to do it, all right? But also, I'm not trying to force you to learn a bunch of different ways to do the same problem. So some of you, if I try to show you a different way to do this, you're going to object to that and say, look, you just showed me how to do it. Why are you showing me another way? And for you people, you've got the fast forward button. You could skip through this part, all right? But I think then for your global understanding of everything we're learning, it would be good to see a different way. So I want to say this. Is there another way? Do I have to do this problem with the product rule? Now the truth is, before we learn the product rule, I've showed you problems like this, okay? And we didn't know the product rule yet, so I told you, well, here's what we need to do. We need to multiply all this out into distinct terms and take the derivative of each term according to the rules, okay? So I'll say this. Yes, there is another way to do it, okay? Let's see. Is there another way you could write this function y so that it isn't a product and therefore does not require the product rule? So yeah, you could, I mean, you know FOIL multiplication. You could do that, right? 8 times 2, so I'm going to get 16 minus 8x. That's 8 times negative x. Minus 4, so I got negative 2 and 2, x to the third power. And then plus 2x to the fourth power. Okay. So let's see. Can they even, so 4, 3. Yeah, I can't combine any of that. None of those terms are like terms. But I can find the derivative of this according to rules that we learned before we even learned the product rule. Okay? So what do? One term at a time. Here's what we do. What's the derivative of 16? Well, 16 is a constant, so 0. I carry down the minus. What's the derivative of 8x? That would be 8. What's the derivative? Carry down the minus again. Carry down the 4. Carry down that coefficient of 4. What's the derivative of x to the third power? That'd be 3x squared. Okay. And then we carry down the plus. right? That's what the rules we learned said to do. And what's the, and the coefficient of 2. And then what's the derivative of x to the 4th power? That'd be 4x to the 3rd power. And if I did this right, I should get the same answer. It's a math question. There's only one answer. So y prime is, let's see, negative 8 minus 12 x squared plus 8 x to the 3rd. Is that the same answer? Is that the same answer? Let's see, 8x third minus 12x squared. It's the same answer, all right? Not that I really had any doubt because I knew both methods would work, but, you know, you have your options, all right? You can use the product rule to do this, you see, and we get total agreement if we use other rules understood correctly and used correctly, okay? I'll just leave that with you. I'll let you do with that what you want, but I showed you what I needed to show you about that problem. Now, I know what your next question might be. If you don't have to use the product rule, why did I bother showing it to you? Well, okay. It's for problems really that aren't reducible by algebra. I can, by algebra, reduce this problem in a way that I don't need the product rule. But that's not true for every type of problem. I mean, it just isn't, okay? So I'm going to give you like just a note kind of on the side here. And let me tell you this. I'll tell you way more about this in another video. But for now, I just need to get it out there. The derivative of sine is cosine. And the derivative of cosine is negative sine. Okay? So that's the derivative of the sine and the cosine functions. What are the, you probably, natural that you take those for granted. What is the sine and the cosine function? Well, so if I drew a right triangle right here, the sine of that angle is, I could actually do it this way if you want to. I could measure the opposite side of this triangle, and then I could measure the hypotenuse, and I could divide those numbers, and that's the sine function. Okay, so yes, sine and cosine are functions. X is considered to be an angle. But there's their derivatives. Okay, now for me to review the whole nature of the sine function, that'd be a class called pre-calculus, but I'll tell you a little bit about it right now. So could you do this? Could you find the derivative of x times sine x plus cosine x minus 7? Can you do that? All right. Well, so let's see. I don't have a problem with the 7 or the cosine. It's the x times sine of x that is a product that requires me to use the product rule. Okay? What about the rest of this stuff? Well, let me remind you. I mean, the way it is, there's lots of rules. The more we go through the class, the more rules there are going to be. You got to get a handle on them. That's just the way it is. But remember when I told you about this rule that I said, suppose you have one function plus or minus another function. Not one function times another function, but one function plus or minus. Then the derivative of that, well, the plus and minus does not complicate anything. You take the derivative of that first function, and you either add or subtract the derivative of that second function. So this plus, like, I'm just going to carry it down and tell you the derivative of cosine. And that minus, I'm just going to carry it down and tell you the derivative of 7. But for this part, this first term, x times sine x, I got to use the product rule. So for me to do that, let's call that first function x, we'll call it f. And the second function, sine x, we'll call it g. Okay, so here goes. What is y prime? All right, so I tell you the derivative of this first thing plus the derivative of that second thing minus the derivative of the third thing. That first thing requires the product rule, okay? So the product rule, as I told you in the first slide, is going to be f prime g plus g prime f, okay? So I will do that. Let's see, and I'm going to put that all in parentheses just so that it stands out from the rest of my problem. F prime times g plus g prime times f. Okay? Can you agree with that? F prime. What's the derivative of x? It's 1. Times g. Well, g was sine x in my setup when I was going to use the product rule. And then g prime. What's the derivative of sine? Well, I know I just told you that, and I haven't elaborated much about it, but I did tell you the derivative of sine is cosine, so cosine. And then times f. What's f? Well, that was this function x. Okay, so there's the product rule. So this whole thing in there, and I'm going to write more to finish the problem out, but that is the product rule, at least as it unfolds in this problem. Now I'm on to this plus right here. What do I do with the plus? I carry it down. What's the derivative of cosine? Well, again, I haven't elaborated too much about it, but I did tell you that derivative of cosine is minus sine. So I'm going to say minus sine, okay? And then I carry down that minus because that's what you do with pluses and minuses. And then I say, what's the derivative of 7? 7 is a constant all by itself, so that would be 0. All right. So there, I've got my problem worked out. Now, from here, I'll do whatever simplifying I can. So let's see. This parentheses is only there because I wanted the part of this problem that was the product rule to stand out from the rest of it. It doesn't accomplish anything other than that. I might as well just circled it with my red pen or something like that. But here's what we got there. We got 1 times sine x. That's going to be sine x. And plus, let's see, cosine x times x. I think it's a little bit better to write the coefficient in the front right there. So I'm going to write this as x cosine x. And then I've got plus negative sine x. Well, I might as well say that's minus sine x. And then I've got minus 0. Well, I mean, what's the point in writing minus 0? We'll just say 0. It's not there anymore, all right? Okay, does this simplify any further? Well, I've got sine x and minus sine x. Those cancel. And so my y prime is just going to be x times cosine x. All right. And that's it. Okay. So that's how we might use the product rule in something that is irreducible. I got x times sine x. There's no way to write that any other way than it is. There's at least not any other way to rewrite that makes it simpler. So I think you're stuck using the product rule with that one. Now, this next problem I want to show you is another one that you don't need to use the product rule for. But, you know, if I don't show you this, like, people are going to do this problem by the product rule anyway. And I want to try to discourage that. But at the same time, I figure if people are going to use the product rule, I might as well show them how to do it, because I think they'll do it that way whether I show them or not. So I just feel a little bit better showing you. Here's what I'm saying. So for a fairly basic problem like 7x squared, in my experience teaching calculus and grading tests and hearing what people have trouble with, and many people will use the product rule on that when they learn the product rule. So they'll see this like f is 7 and g is x squared. Okay? So if I use the product rule, f prime g plus g prime f, then that will work out like this. So if f is 7, what's f prime? What's the derivative of 7? 7's a constant. That would be 0. So f prime g is x squared, plus g prime. Well, g is x squared. What's the derivative of x squared? That would be g prime. That will be 2x. And then times f. What's f? F is 7. What does all that end up being? 0 times x squared plus, well, I got a 2 and a 7, so we'll say plus 14x. So 14x. All right, so that's what I get by the product rule. But I know, like with the other assignment and the videos I've already made, you already know how to do that. You've seen me work problems like that already. So let's do like this. And, you know, again, like some people aren't going to like it that I'm showing you different ways to do the same problem, but that's really just reality, that there are different ways, and whether I show you them or not, people will wonder about them and be curious of how they should do it. Okay, so say forget about the product rule. I just showed it to you. All right, you saw it. Forget about it though for just a moment. How did I tell you that you could do this before? There was a rule that we learned that said if y is a constant times a function, so that number is a constant, and that's some kind of formula that involves x, then the rule that I gave you in another video was you'd take the derivative of such a thing like this. You carry the constant down, and you multiply it by the derivative of that function. So you don't have to use the product rule for this one. I mean, 7's a constant, isn't it? Okay. So y prime would be, so carry down the 7, but then multiply it by the derivative of this. So what's the derivative of x squared? That would be 2x. Okay, so your answer is 7 times 2x. What's that? That's 14x. Okay? All right. Well, yeah, I got the same thing. You know, it's a math question. There's only one answer. Both these ways are valid. I'd rather see you do this problem with that rule because it's obviously easier, all right? But, you know, it's up to you. It's not like it's against the law to use the product rule to do that problem. So if that's what you want to do, you can do it that way. But let me stress this. The product rule is for generally a product of two functions, formulas, that both involve a variable, like 8 minus 2x to the third and 2 minus x. It's not really intended for the product of a constant in a function. That's what this rule is for, okay? This rule will be easier to use if it's a constant times a function. But can you still use the product rule if it's a constant times a function? Yes, you can. You still get the same answer. So I'll just say that to you. I'll bring your awareness to it. But, you know, if you like to do it this way, you know, I guess you could do it that way. All right? But I want you to practice the assignment. You have to get a feel for what works for you. You saw the video. You see your options. From there, it's time to practice.